Iedereen van harte welkom bij dit webinar. We zijn ontzettend blij dat er zoveel mensen zich hebben aangemeld en meekijken met ons webinar. We denken ook zeker dat het de moeite waard is. En we hopen dat waar te kunnen maken. Hoe ziet ons webinar eruit? Er zijn een aantal spelregels. Iedereen die volgt, alle consultants, die zijn gemute. Vragen kunt u wel stellen, dat kunt u via de chat doen. Die kunnen eventueel direct beantwoord worden of na afloop, als daar tijd voor is. Als u dat liever in het Engelse deel in het Nederlands doet, dan zullen wij die vertalen. En anders kunt u dat gewoon in het Engels doen. Hoe zal het er verder uitzien? In eerste instantie zullen wij iets vertellen over de VVB. En vervolgens switchen we naar het Engels en zullen de mensen vanuit Amerika, professor Barbano en Dr. Dan, een presentatie verzorgen over de vetzuren en de nieuwe waarden. And special welcome to you, Mr. Barbano and Ms. Dan. We're very happy to have you here and that you're willing to do a presentation for our people here in Holland. Mijn naam is Jelle Koopmans. Ik ben voorzitter van Veluwe IJsselstreek. Ik zal er straks iets meer van vertellen. Vooral omdat het opgegeven gezelschap heel gemêleerd is. Heel veel mensen uit allerlei windstreken van Nederland, maar ook verschillende bedrijven die ons wel of niet goed kennen. Dus een kleine introductie, zo kort mogelijk. Naast mij zit Marissa. Marissa is eigenlijk de Matthijs de Licht van VVB Veluwe IJsselstreek. Zij is ontzettend jong en toch heel ervaren. En in wezen ook al onmisbaar. En zij zal vertellen straks hoe de uitslag eruit ziet zoals die bij de boer binnenkomt. Marissa?
Ja, mijn naam is Marissa Verruler. Ik ben sinds enkele jaren werkzaam bij Veluwe IJsselstreek. En een van mijn taken is het versturen van de NPM of de uitslag van de vetzuren. En deze zal ik nog even toelichten hoe die er precies uitziet en wat die inhoudt.
Gaan wij nu naar de presentatie. Ja, de presentatie, de webinar wordt georganiseerd zoals gezegd door Veluwe IJsselstreek. Maar wij doen dat samen met Cornell University. Daar werkt professor Barbano. En met Uniform Agri, en dat komt in de presentatie ook nog. Zij ondersteunen ons met alle software en allerlei dingen die wij organiseren. Ter informatie, in de chat mochten wij antwoord geven, dan zal er ook staan Guido Eipelaar. Wij doen dit bij Uniform Agri op kantoor. Vandaar dat zijn naam in beeld verschijnt, maar de antwoorden zullen door ons van Veluwe IJsselstreek worden gegeven. Nou, wie is Veluwe IJsselstreek? Wij zijn een vereniging met 1100 leden. 100.000 koeien in de melkcontrole ongeveer. Wij zijn, dat is leuk om te vertellen, relatief klein, maar in een moeilijke markt groeien wij nog steeds. Waarom is dat? Nou, eigenlijk door de punten die hieronder staan. Goede service, persoonlijk contact. Een kleine groep mensen die zich keihard inzet en heel enthousiast is en heel betrokken is, die zorgen daarvoor. Waarin zijn wij dan uniek? Nou, we hebben een eigen NPR-uitslag. Belangrijkste misschien wel, we hebben een eigen laboratorium. En daar kunnen wij zelf meten en daar kunnen wij ook snel mee werken. Omdat wij klein zijn, hebben we scherpe tarieven. En zo zijn er nog een aantal zaken. Misschien leuk om te vertellen. De presentjes die wij geven bij jubileumkoeien vinden wij heel belangrijk om daar veel aandacht aan te geven. We hebben een ontzettend getalenteerde kunstenares. Ze is 75, maar ze heeft de geest van iemand van 25. Dus ze maakt waanzinnig mooie cadeaus. Als je dan een jubileumkoe hebt, dan is dat eigenlijk dubbel feest. Feest voor de koe, maar ook vanwege het fantastische schilderij wat u ontvangt. We zijn, het voordeel van onze omvang is dat we klein genoeg zijn om persoonlijk te zijn, maar ook groot genoeg om slagvaardig te zijn. Wij kunnen hele goede dingen bieden, maar dat kunnen we alleen in samenwerking met partijen. Uniform Agri heb ik al genoemd, maar daarnaast is Perkin-Elmer een hele belangrijke speler. Perkin-Elmer is de instrumentleverancier bij ons in het laboratorium. De combi's die wij hebben, die de melkmonsters onderzoeken, worden geleverd door Perkin-Elmer, die in Drachten een kantoor hebben. Perkin-Elmer zorgt er ook voor dat we de modellen met de vetzuren hebben. Perkin-Elmer is zeer innovatief en die loopt voor in de markt. En wij plukken daar de vruchten van. Dat is fantastisch voor de VVB en dat past ook bij ons. Zo proberen we ook te zijn. Maar goed, als je iets kan meten, maar je kunt het niet goed presenteren, dan heb je er nog niet zoveel aan. En daar hebben we dan Uniform Agri voor. Uniform Agri zorgt voor de presentatie van de NPR, van de getallen die we meten. Maar zij doen niet alleen dat voor ons. Zij leveren ook de software op kantoor. En zij hebben bijvoorbeeld een managementprogramma, wat wij ook als VVB bedrijfsmanager aan onze leden aanbieden. Nou, daarnaast helpen zij ons bijvoorbeeld als we per ongeluk een keer een webinar organiseren. Tot slot, die nieuwe uitslag en die nieuwe getallen die wij bieden. Hoe verspreiden wij die? Nou, er zijn eigenlijk een aantal groepen te herkennen. De veehouders zijn de belangrijkste, want het gaat om de koeien van de veehouders. Wij kunnen de NPR inclusief nieuwe kengetallen naar iedereen versturen. Mensen veehouders die beschikken over een Uniform Agri of VVB bedrijfsmanager managementpakket of ook AgroVision, die kunnen dat ontvangen in hun managementsysteem en in dat systeem ook verschillende analyses doen. Boeren die met andere managementsystemen werken, die kunnen de nieuwe waarden, dus de toevoeging op de NPR-uitslag, ontvangen via een PDF. Op die PDF staat precies alles wat ook ingelezen kan worden. Dus alle attentiekoeien. Enige nadeel is dat je dan niet verder kunt analyseren. Uiteindelijk is het best heel ingewikkeld de nieuwe getallen goed te interpreteren voor veehouders. Daarom is deze webinar ook gericht op voeradviseurs en dierenartsen. We vinden het heel belangrijk dat jullie de getallen begrijpen. Dat is een onderdeel van de webinar. Maar ook mee kunnen nemen bij de adviezen die jullie geven op de boer. Daarom is het van belang dat ook jullie als adviseurs de waarden in kunnen lezen en jullie programmatuur. Wij zijn daarvoor in gesprek met voerleveranciers en hun softwaremakers getreden. En het goede nieuws is dat eigenlijk alle grote partijen, van Rovecom tot AgroVision met Optivoer, maar ook Koerhuis, allemaal de mogelijkheid gaan inbouwen om de nieuwe kengetallen te presenteren. Dus straks als de voeradviseurs op pad gaan naar de boer, dan hebben zij de nieuwe kengetallen en kunnen zij al advies voorbereiden voor de veehouder voordat zij op het bedrijf zijn. Bij de dierenartsen is dat wat lastiger, omdat het programma van dierenartsen is PIDAP. Bij PIDAP zijn ze nog niet zo ver dat ze in willen bouwen dat getallen ingelezen worden. Daar kunnen wij wel samen met Uniform Agri de consultant versie aanbieden. Daar kunnen meerdere bedrijven ingelezen worden en ook analyses gedaan worden. Daarnaast zijn de gesprekken net opgestart met Vetwerk. Vetwerk is een nieuw softwareprogramma dat een beetje aanvullend is voor dierenartsen. Dierenartsen die eigenlijk nog dichter op de boer willen zitten en betere adviezen per koe willen geven. Dus daar zijn gesprekken mee gestart om het daar wel in te gaan bouwen. Dus als u het in PIDAP wil hebben, moet u misschien contact opnemen met PIDAP. Als iedereen dat wil, zullen ze misschien gaan schakelen. En anders dan kunt u de consultantversie of wellicht dat Vetwerk een optie wordt. Dan geef ik nu het woord aan Marissa. Zij zal gaan vertellen over de uitslag.
De meeste van jullie zullen de uitslag zoals wij die presenteren aan onze veehouders al wel kennen. Dit is een uitslag wat we samen ontwikkeld hebben met Uniform Agri om dit snel te kunnen versturen naar onze veehouders. Voor degenen die het nog niet kennen, leg ik even uit hoe het werkt. De informatie achter de getallen, dat zal verder toegelicht worden door professor Barbano en dokter Den. Wat wij presenteren voor onze veehouders is dus de uitslag met de bloednefa en de denovo. Voor de gebruikers die ook een uniform managementpakket hebben of een AgroVision managementpakket, wordt dit ook in het managementpakket gepresenteerd. Voor degenen die dat niet hebben, die ontvangen dus de uitslag die u nu ziet op het scherm. Hierin geven we een weergave van de bloednefa, de denovo en een attentielijst voor de dieren die een attentie laten zien. Even goed. Dit is de grafiek van de bloednefa. Aan de linkerlijn ziet u dus de bloednefa-waarden staan en onderaan staan de dagen in lactatie. En de dieren die u ziet staan, dat zijn de puntjes met de diernummers erbij. En op die manier is dus goed te zien of een dier last krijgt van slepende melkziekte en hoe de opstart gaat van de verse dieren of de koppel die dus net afgekalfd heeft. Daaronder staat een grafiek over de denovo. Hier links staan ook weer de denovo-waarden. Onderaan zijn de dagen in lactatie te zien. En ten opzichte daarvan zijn de dieren ook weer puntsgewijs weergegeven. En op die manier heeft de veehouder of degene die op het bedrijf komen snel in kaart van hoe gaat de opstart van de dieren? Moeten we daar wat aan sleutelen? Gaat het op individueel niveau wel of niet goed? Of is er eventueel wat mis met het rantsoen? En op die manier heb je gewoon maandelijks goed in beeld hoe het gaat met de opstart van de verse dieren. Helemaal onderaan de lijst staat een attentielijst. Hier komen alle dieren te staan die een afwijking laten zien bij de bloednefa of de denovo. En daarachter staan de dagen in lactatie. De dagen in lactatie zijn wel essentieel omdat een dier die dus net afgekalfd heeft, die bijvoorbeeld 5, 6 dagen in lactatie is, die laat hogere bloednefa-waarden zien dan een koe die bijvoorbeeld al 30 dagen in lactatie is. En daarmee kan je dus goed zien van ligt het net aan het afkalven of is het een dier die in één keer een slepende melkziektewaarde laat zien en moeten we daar even naar kijken. Ook laten we de bloednefa-waarde nog op de individuele uitslag zien. Zo kan je even goed kijken hoe het verder staat met de waarde van de koe. En of het een opvallende waarde is, ja of nee. Tot zover de uitslag van de vetzuren zoals wij die presenteren. Als er nog inhoudelijk vragen zijn over de uitslag, dan kunt u contact opnemen met ons kantoor of de vragen stellen in de chat. En de achtergrondinformatie achter deze waarden die zullen nu toegelicht worden door professor Barbano en Dr. Hiervan.
Now it's time to switch in language. We're gonna start now with the presentation of Professor Dave Barbano and Dr. Heather Dan. I'm proud that I can introduce you. We have had you, Mr. Barbano, already once in Nunspeet in a meeting with consultants. That was some years ago. We were actually expecting you last year to give a presentation in Nunspeet, but then suddenly COVID arrived, which was a big disaster for everybody. And it took a while. In first instance, we were disappointed that it was not possible to do the meeting. And at a certain moment, ring the bell, and in a way, everything is more easy now. So with a webinar, we can still answer all the questions. We can still give you the chance to give a presentation for the consultants here in Holland. And we're very happy to have you. I know you now a few years, and you're a very special person. Special because you have the age and the intelligence to be very experienced and a lot of knowledge. But on the other hand, you have the drive of a person of 25. And that is really fantastic. That's not the only thing. The other thing that makes you special is that you are able to build a bridge to connect science and practice. It's amazing how much you're always interested in really the results on farm level, on cow level. And that is, in a way, also what we are searching for here with our advisors. We want to translate the new values to practical information for the consultants so that they can help the farmers in their management, so that they can help them to improve the health situation of cows. You promised to give a presentation. I asked you to not just go into bulk tank, but also individual cow, because that is what we do with the milk recording organization. And then you told me there is one person that I really need who is better than I am in that area, and that is Miss Heather Dan. And luckily, she is also willing to assist you in this presentation, and we're very happy also, Heather Dan, that you are here, and we're looking forward to hear what you have to say. And that's my introduction. I pass the word to Mr. Barbano. I understood that you're going to do the first part of the presentation, and that meanwhile you will switch with Dr. Dan.
Yes. Thank you very much. And I can't see anyone, but I assume that there's a number of people, some faces that I've seen before when I was in Holland doing a presentation. And this is an update of that and some additional new work that we've completed that focuses more on the use of milk data with individual cow health. So that's I'm really pleased that Heather Dan from the Minor Institute was able to join us today, because we've worked collaboratively on this for quite a few years now, and they have an active dairy farm with Holstein cows, and we have the research lab there, and also a Delta combi or a Perkin-Elmer combi now that we're routinely analyzing the milk from many individual cows every week on that farm to better understand how to use the milk analysis data. So with that, if we can switch the screen to the presentation, I'll get started. Okay, I can see. Okay, I guess I'm not getting the screen of the slides. So is the slide screen going to display, or am I going to stay? Okay, I see a small version of it. So I'd like to acknowledge Heather Dan and the group from Minor Institute, and also part of the results that will be presented today are from another colleague that I'm working with at the Cornell Veterinary School, Jessica McCart, and the last part of the presentation will be some brand new data on individual cow milk analysis and how that data can be used.
Nee, ik krijg niet het beeld. Nee. Waarom doe ik gekke dingen niet? En ik even stoppen, bergen.
Is it working?
No, give us a minute.
Okay.
Hoe kan ik die krijgen naar het andere scherm?
We're struggling a little bit with the screen, but the good news is that we have already 100 people following us. So I guess it makes the people of Uniform Agri a little bit nervous, but I'm sure that they're gonna manage soon to get the screen there.
Okay.
Als je nu even opnieuw deelt. Kijk ook deze. Moet je delen, eerst even stoppen. Deze. Dan moet ik mijn eigen scherm hebben. En dan moet je het deelscherm weg doen. Ja. Die. En dan moet ik nu naar deze. Ik krijg niet gedeeld. Ik heb heel meer zitten oefenen. Dat is vreemd. Deeltje scherm. Waarom zou dat nou niet kunnen? Is goed voor nu. Deze. Kijk, nou doet je het wel. Zie je dat? Wacht even. Waar staat hij ook heen? Je hebt een beetje PowerPoint afgesloten. Ja, klopt. Ja, dan heb je die PowerPoint weer open. Kom op. Ja, komt eraan.
I may be able to share from my computer if you want me to try.
We're almost there. I hope.
Okay.
En hij deelt nu dat scherm, hè?
Ja, precies.
Dus dan moet je even die even op de andere ding zetten. Juist. Nou,
Hey.
is dit de eerste sheet?
Dit is de eerste. Ja. Go on.
Okay.
Yeah.
So I'd like to acknowledge collaborators. Heather Dan is with me here at the presentation. Jessica McCart from the veterinary school. The Tom Overton is in the animal science department. Alex Caterina Melilli from Italy, and Rick Grant, who's the president of Minor Institute, are all collaborators in this, and we're very happy and honored to be doing a presentation of something that all of us have invested a lot of work and effort in and are really proud of in terms of what we're doing for the dairy industry. Next slide. Okay.
Oh, excuse me.
So,
Pak het twee tegelijk.
okay.
This one.
Yes. So we're going to give a presentation. We'll do some basic background work in terms of the vision of what we have and the use of milk analysis data going forward. I'll explain a little bit about milk fat structure and milk fatty acid composition as it relates to feeding and health of dairy cows. And then we'll define what denovo, mixed, and preformed fatty acids are. We'll go through this fairly quickly because I think many of you have seen this before, and get on to the two main parts. Item 5, where we look at the relationship between fatty acid composition of milk and the fat and protein test, and how both the fat and protein tests change seasonally, but what's happening to de novo, mixed, and preformed. The item number 6 is where we'll really focus on when we look at individual cow milk composition data. You really have to start thinking a little bit differently because we have to consider the stage of lactation and the days in milk of the dairy cow. Next slide. So the overall vision is to develop new analytical tools for bulk tank and individual cow milks that will support decision-making for management of feeding, which we'll get to composition and paycheck, health, and reproduction in dairy cows. Next slide. So in terms of what we call the triglyceride, 99% of the fat in milk is made up of this chemical structure. The structure has kind of a base unit or backbone that is the glycerol, and attached to that chemically, there's 3 fatty acids. These fatty acids can vary in the number of carbons, and in this cartoon that's on the screen, each one of those points of the black line is a carbon. And sometimes the connecting line between them is a single bond, sometimes it's a double bond, which we call an unsaturated bond. And so that varies in the fat from cow to cow, across time and lactation, from farm to farm, in the length of the chains and the degree of unsaturation or double bonds. So the infrared is looking inside the milk to give me information and a vision of what these structures are and how they're changing when we change feed or when the health status, the days in milk change for the dairy cow. Next slide. So there's 3 groups that we organize the fatty acids in, and you'll see to the left in this slide the C and a 4 with a colon and a 0 after it. What that means is it's a fatty acid with 4 carbons. It's a short one. 0 means it doesn't have any unsaturation or double bonds. If we look at the word denovo up at the top in the left, there's a circle under it. All of those fatty acids within that circle can be made from the products of the rumen fermentation that are transported through the blood, primarily acetate and butyrate, to the mammary cells. And the mammary cells, with those 2 carbon units, the acetate, can add them 2 at a time to build a fatty acid as long as 16 carbons, which would be over here in the right part of the circle on the left. When we look at the second group to the far right is preformed. Those fatty acids come from the diet and from adipose tissue in the cow through the liver. So they're from 16 carbons to greater than 18 carbons. We call those preformed because they're not made within each individual mammary cell. They're transported through the blood to the cell and used preformed. You'll see that the 2 circles overlap, and the 16 carbon fatty acids can come either from synthesis within the mammary gland or preformed. So we call them mixed origin. They're in the middle. They can come from both sources. What's important to realize is that these 2 groups, the de novo and preformed, represent differences in the source and the origin of the material that's being put in the fat that is output in the milk. And how the balance of these 2 change tells me something about how the cow is either reacting to feeding changes or how something is changing in her health that is giving me information that I can tell from the milk without having to take blood samples. You're probably hearing a sound in the background. I repair and collect antique clocks, and it's 10 o'clock, so there's likely to be some noise from my antique clocks in my office. The next slide. So here's a picture of a cow. She eats feed. In the rumen, there's a fermentation that produces acetate and butyrate by the microbes. Those 2 compounds are carried through the blood, go to the mammary gland, and they're used in the de novo synthesis or synthesis within the mammary cells to make milk fat. Next slide. Next slide.
Dan. Hij gaat hier weg.
Okay. This is the preformed fatty acids. The cow eats feed. There's some of these 16 and 18 carbon fatty acids that are in the structure of corn, soy, as fat that was made by the plants. That fat is converted to saturated fatty acids, goes into the bloodstream. So the blood is the highway and can either be taking those fatty acids to fat storage or adipose, or an early lactation when the cow is mobilizing body fat, that adipose is being broken down through the liver to be taken by carriers to the mammary gland as preformed fatty acids that support the synthesis of milk fat. Next slide. Next, we're going to talk about the relationship between the milk fatty acid composition and bulk tank fat and protein test, and how all of this in terms of the fatty acid composition of the milk fat changes seasonally in bulk milk. So this is from farms, not individual cow milks, but it's interesting to have this perspective because it's helping us, particularly in the region of the United States where both Heather and I are very active, in understanding why the fat and protein change seasonally and things we can do to avoid the fat and protein going too low during the summertime. So next slide. We do this testing with the Delta, either the manual FTA or in the smaller photo on the right, the combi type unit, which is what VVB has. And these big machines will test up to 600 samples per hour and give you everything, the fat, the protein, the urea, the fatty acids. And as we add new metrics, the same machine will be able to give us additional information about the milk. Particularly when we talk about individual cows, in addition to the de novo, mixed origin, preformed, you'll see in the top above the instrument, we also measure an estimate of blood nefa from the milk, the beta hydroxybutyrate and acetone content of the milk. Next slide. So here is really kind of the beginning when we started doing this and realized that when we could look at what's happening to the individual portions of the milk fat, that we saw in Holstein cows on the left, that as the de novo fatty acids increased in concentration, and this is grams per 100 grams of milk, which is the same unit as your fat test, is grams per 100 grams of milk. So here we see that as the de novo fatty acids in Holstein cows increase, the bulk tank fat test increases. On the right, there's the same information for Jerseys. The R squared is a little bit lower, but this is a fairly strong relationship in both breeds. And generally the same trend is going on so that we can maximize the fat test in the bulk tank, the milk you're selling, by maximizing the de novo fatty acid production. So this is what we see for de novo. Next slide. So if we combine this is the mixed origin, we see the same relationship with fairly high R squared. And this relationship, as we've found when we've looked at different breeds, holds across breeds. The fat level in Jerseys is higher, but the relationship is the same. And I think the important thing to recognize is inside a Jersey and inside a Holstein, the biochemical pathway, the method of synthesizing these fatty acids is exactly the same. So we'd expect them to have the same relationships. It's just the Jerseys genetically seem to be able to do a bit more of this than the Holsteins. Next slide. The de novo and mixed origin, because now we remember that from the synthesis, the mixed origin fatty acids can be produced by the de novo pathway. And this source of mixed origin fatty acids is the predominant source of the palmitic or mixed origin fatty acids after the cows become positive in their energy balance, that most of the mixed origin is coming from de novo synthesis. So we see an even stronger relationship with the fat test, both in Jerseys and in Holsteins, with an R squared of 0.88, 0.85. This is a very strong relationship. So focusing on these to understand if these are going up, it's a good thing. Preform doesn't have this relationship with bulk tank. Next slide. Here we show the change in preformed fatty acids as a function of fat test. And the important thing is to look at on the regression under the Holstein graph, the R square now is only 0.06. Very low correlation with the fat test in the tank. Same thing on jerseys. So really, we focus on the denovo or denovo plus mixed origin to maximize bulk tank fat test. Next slide. When we do this, we get a bit of a bonus. That when we increase, and we've studied this now both in jerseys and Holsteins, that when we increase the output of the de novo fatty acids, the protein synthesis increases also, particularly if the diet is properly balanced. The regression relationship isn't as strong as for fat, but the same thing happens in both breeds, jerseys and Holsteins. And this is because when the de novo synthesis in the mammary cells is high, it's telling me that there's a lot of substrate being produced by the fermentation in the rumen. The rumen microflora are producing a lot of acetate and a lot of butyrate. They're breaking down forage very well. When they do that, if we could look inside the rumen, the population of microbes is being maximized. There's a very high mass of microbes in the rumen, and those are digested as the rumen contents moves to the next portion of the digestive system of the cow. The important thing is those microbes contain a lot of essential amino acids that they made that are in the structure of the microbes, and the cow digests that and uses those essential amino acids. Those essential amino acids are needed for the cow to produce more milk protein. So it's really a very win-win situation of if we follow the de novo fatty acids and maximize that, we'll have good things happening in terms of protein synthesis also. Next slide. So now that we've had much more time and data on this, we're starting to aggregate the data in the northeastern United States where Heather and I are. And this is for 40 Holstein farms in a cooperative in the northeastern United States where we have data on them every pickup. Every time the milk is picked up, we have the fat test, we have the fatty acid data, we have the protein test. And as we start to look at that across time in the calendar sense, when we see the red line is the fat test, and we see the seasonality in July, August, the fat test is the lowest. In January, February, the fat test is highest. And this is a typical seasonal variation. This is the average for these 40 farms, but we see this in factory milk. What was very interesting is the de novo, the blue line, is following exactly this same cycle. So the up and down of the fat test seasonally is driven by the de novo synthesis of fatty acids, which we can influence by nutrition and how we manage the cows. So this was a very important view that we'd never seen before. Next slide. Here, we've got the de novo fatty acids and the protein test. So this is de novo plus mixed. And we see that the protein test, which is the red line, is cycling the same way with the de novo or the de novo plus mixed in this case. And so this is a really important understanding too, that the seasonality in protein test really is linked to what we do and how we feed the cows and the quality of the feed and heat stress during the summertime that influences this synthesis. So it's all connected. And if we manage the de novo fatty acids and the de novo synthesis, we're also going to get benefit in managing protein content of the milk too. Next slide. And I'll turn it over to Heather at this point, and she'll pick up from here.
Thank you. So here we have a table that our nutritionist here in the US will reference. This is summarizing the relationships that we see between milk fat content and the fatty acid metrics. And the first row of the 40 Holstein herds, that summarizes data that came from the St. Albans group that Dave just shared with you. And we also have looked at other parts of the US to make sure that these relationships hold true and aren't just unique to one region. And we would think that these types of equations would apply to other parts of the world as well, especially for Holstein cows. We also looked at Jersey herds across the US to see if their relationship for the fatty acid metrics and fat was similar to Holstein herds. And for the most part, what we see is similar slopes to the line. The only difference really is that the Jersey fat and milk fatty acid components are shifted to a higher level compared to the Holstein herds. So what we're doing is using these equations to better understand what value should I expect for a farm if I have a target goal of fat content of 4%, for example, or 3.8 or 4.5. And so what it allows people to do is say, based on the fatty acid metrics, are my cows producing as I would expect or not? So these regression equations have been utilized for whole herd milk samples, but we can also kind of use them to give us some indication of what we might expect for individual cows. Although as we get using them for early lactation or cows in late lactation, these equations won't hold as true because these equations were developed for cows that are more in the mid part of their lactation. But the one thing that I take away from this data is that if we focus on de novo fatty acid, that has a very strong relationship with the fat content. And here in the US, a goal is to increase the amount of fat that is produced. So if we use this information, we can look and see that for every 1/10 increase in de novo fatty acids, that we would expect a 0.2 percentage unit increase in milk fat. Next slide, please. So we did a study over a couple years looking at herds that were feeding their cows and had different levels of fat content that they shipped to their co-op, and then also characterized those herds based on their de novo fatty acid content. We looked at herds that had high levels of de novo fatty acids and herds that had low levels of fatty acids. We wanted to understand what nutritional and management practices impacted the production of de novo fatty acids. And on the diet side of things, what we found was that cows that are fed diets that are lower in total fatty acids, so have a lower ether extract, produced more de novo fatty acids and had higher milk fat. We also found that the physical form of the carbohydrates that the cows are offered, in this case the physical fiber, was critical. And herds that had fed more physically effective fiber, in this case greater than 21% of the dry matter, they had higher de novo fatty acids in their milk and therefore higher milk fat content. Next slide, please. We also realize that it's not just what the cows are fed, but how that feed is offered to the cows and the availability of feed throughout the day. We found that herds that have higher de novo fatty acids were more likely to deliver their feed at least twice a day in free stalls when that feed was delivered as a total mixed ration. In tie stall herds, where many might feed component fed, indicating that different herds are fed at different times, the herds that were feeding at least 11 times or at least 5 times per day were more likely to have better milk fat components driven by this higher de novo fatty acids. Next slide, please. In addition to the feeding and feeding management, we found that just how cows are housed has an impact on the production of de novo fatty acids and milk fat. Higher de novo herds tended to be 10 times more likely to provide at least 46 centimeters of bunk space per cow. Now, I think many of us that work in the field would argue that still 46 centimeters isn't a substantial amount, but given how many of our cows are housed in the US, this is a realistic goal for some farms to reach. We also found that the high de novo herds were 5 times more likely to stock the stalls at less than 110%. So hopefully we don't have many herds that are overcrowding cows like you see in this picture. But if a farm is doing this type of overcrowding, we would definitely expect lower de novo fatty acids issues with production and rumen health. Next slide, please. We're not the only ones to have looked at risk factors for lower milk fat on herds. This is a study that was done again in the US with about 79 herds that were feeding Minensin, which is that INF4 antibiotic that improves feed efficiency across lactation, but has the opportunity to decrease the risk of ketosis in early lactation cows. What they found in this study that fits very nicely with controlled research is that as the content of trans C18-1 fatty acids increases in the milk, that they were negatively related to overall milk fat content. And so these trans 10 C18-1 fatty acids are products of the alternative pathway of ruminal biohydrogenation. So this typically, the shift in pathway occurs when too much polyunsaturated fat is fed in the diet, the wrong types of fatty acids are fed, or there's a change in the rumen pH that may be in response to too much fermentable carbohydrates. Next slide, please. So similar to what we saw, they have also seen that when milk fat content was strongly related to the production of de novo fatty acids. And what they found was that in this study anyways, that the preformed fatty acids were lower in herds with a higher bulk fat or bulk tank milk fat. So in the work that we've done, we haven't seen a very strong relationship. So I think from both the work that we've done as well as this study is good evidence that nutritionists and farmers really need to focus their emphasis on the production of de novo fatty acids when they have the goal of increasing milk fat content. Next slide, please. So a key focus area for nutritionists and farmers in the US that are using this type of information is really working with the farmers to make sure that the diet formulation and delivery is correct, and then making sure that the cows are housed in an environment that promotes cow comfort, appropriate natural behaviors that allow the cow to eat and rest to be able to produce as much milk fat and protein as possible. Next slide, please. Now, most of the work we've showed so far has been focused on bulk tank. What we're seeing is very progressive. Nutritionists and farmers are realizing that there's more value to looking at smaller groups of animals in the herd to make a management or nutritional change. That's because, at least on our larger farms, cows are housed in groups focused on the physiological state or their production level. And so it allows then a producer to fine-tune a diet or management to that particular group. And then knowing what kind of milk and what's in the milk that's produced is going to allow those herds to be more productive. So in this example here, I have a herd that is sampling cows during the fresh period, and they house their heifers and cows separately and feed them differently. And then they also house their high-producing mid-lactation cows in a separate group. Now, when I look at this data, notice that we are looking at the de novo, mixed, and preformed fatty acids. And together, these three groups should sum to about 95% of the total milk fat. And so right away, you can see that the fresh cows are producing more milk fat than the high group cows, for example. We also notice that there is a difference between the fresh heifers and the fresh cows. So we know that fresh cows or mature cows are more likely to mobilize more body condition to support a higher level of milk production than fresh heifers. One of the things that can clue us into the severity of the body fat mobilization to support milk production in early lactation or even mid-lactation is how much preformed fatty acids there are. Those preformed fatty acids, as Dr. Barbano indicated, come from the mobilization of adipose. And in this case, you can see that fresh cows have a higher preformed de novo fatty acid production and content in the milk. We also see that the high group cows, they're going to have a higher level of de novo fatty acids. So when I'm looking at groups of cows, especially when I'm focused on animal health, I'm going to focus in on the de novo fatty acid group as well as the preformed fatty acid group. Next slide, please. Next, we'll move on and talk about the relationship between milk estimated blood non-esterified fatty acid, milk BHB, and acetone, and how we can use those to improve or monitor individual cow health on farm. Next slide, please. The transition period is a critical period in the lactation cycle of the cow. This is a time period where cows are at most risk for developing some type of metabolic or health issue, and then potentially leaving the herd early because of that problem. When we look at the dry period, we know that cows were maintaining or trying to set them up for success in the lactation. And so what we see is that their energy requirement is fairly stable, or if anything, might slightly decrease because of a small decrease in dry matter intake just before the cow calves. Once a cow calves, this is where things get interesting. We see that the requirement for energy for the cow increases substantially because of the demand for milk production. One thing that the cow is challenged with, though, is that the cow can't consume enough feed in early lactation to support that level of milk production. So the metabolic response is negative energy balance. And so the cow is programmed to be able to deal with some degree of negative energy balance, but the severity and duration of this can be the determining factor of whether the cow is healthy and productive in the herd or if she has issues. Next slide, please. So to help with this negative energy balance, the cow is going to mobilize adipose tissue. Advance, please. Can you bring in all of the animation? Just keep clicking through until the blue BHBA shows up. So in this case, the cow is mobilizing body condition in the form of adipose. That's going to result in an increase in non-esterified fatty acids in the circulating blood. That blood is going to go to the liver, and the nefa has a couple different fates there. It can be completely oxidized and serve as an energy source, and this is really how we want nefa being utilized within our transition or early lactation cows. In some situations, the nefa is going to be stored as fat within the liver, and if that gets too high, then we'll see cows with fatty liver disease or hepatic lipidosis. Some nefa is going to continue to pass out of the blood or out of the liver, end up in the mammary gland, and be used to make milk fat from the preformed fatty acids. And so nefa, high levels of nefa in the blood are often correlated with high levels of fat, and in particular preformed fatty acids in the milk. And then nefa can also be partially oxidized to beta-hydroxybutyrate, a ketone that in times when the cow is in severe negative energy balance is going to be beneficial to a certain level, but then once it increases beyond what the cow can utilize effectively, it's going to have some negative consequences, and that's when we see cows with either subclinical or clinical ketosis. Next slide, please. So with that biology knowledge, we can then apply it to understanding how can we use the milk fatty acid composition to better understand how our cows are doing, especially in early lactation. Now at Miner, one of the things that we've done is collected a lot of milk samples from cows throughout the entire lactation period, and we understand how these fatty acid groups are changing. On the left-hand diagram, we see that week of lactation, and then we also see the fatty acid groups expressed as grams per 100 grams of milk. Now, one thing you should note right away is that in early lactation, the preformed fatty acids are very high, and they decrease very rapidly through the first 1 to 2 months of lactation. Now, this is in response to the negative energy balance that the cow is experiencing, that nefa, a portion of it, ending up in the milk fat. The denovo fatty acids tend to be lower in early lactation and then increase as lactation progresses. The mixed fatty acids follow a similar pattern to the denovo. Now, oftentimes when we're looking at bulk tank, we'll look at the fatty acids expressed as grams per 100 grams of milk. But what I found, and Dr. Barbano has found, that is there's some value in looking at the fatty acids expressed as a percent of the total fatty acids when we're looking at individual cow data, or at least data for cows in early lactation. And that's what's being shown here on the right-hand panel. And again, we see a largest percentage of the milk fat coming from preformed fatty acids in early lactation. And then as lactation progresses, that decreases. And the de novo and mixed contributions increase. Next slide, please. Now, at least in the US, we're not paid necessarily on percentages, but on grams or kilograms of milk fat produced, as well as protein. And so in this left panel, I'm showing how the output of milk fatty acids changes. So although the degree of change expressed as grams per cow per day is a little bit different, the general patterns are similar, whether we're expressing the fatty acid groups as grams per 100 grams of milk, grams as a percent, or grams per 100 grams of fatty acid, or total grams of output. Now, what's interesting to note is that a lot of times in this early lactation animal, we're focusing on the de novo and preformed fatty acids, and that we need to note that there's a difference in how those change, as well as the total grams output when we look at cows that are in their first lactation, indicated by primi, or cows that are in their second or greater lactation, indicated by multi. Next slide, please. Now, one valuable metric that we look at when we're evaluating negative energy balance is this blood non-esterified fatty acid. And one of the unique things about the Delta or the Perkin-Elmer instrumentation is that they have a model that we can predict blood nefa from milk. And so that's what is being shown here. And we've characterized this in our herd over hundreds of cows and multiple lactations. And what we see is what we would expect if we actually went and took blood samples directly from those cows. Non-esterified fatty acids decrease rapidly in early lactation, especially when the cow is healthy. And then that level will be maintained throughout lactation. Next slide, please. Well, what we find more interesting to look at is what's happening in the first 3 weeks of lactation. This is during that transition period when cows are at most risk for ketosis, DAs, and other metabolic related issues. What we see is that the nefa decreases rapidly during this time period, and that multiparous cows, those cows that are second or greater lactation, are more likely to have a higher milk predicted blood nefa. Next slide. So what we do is, for our herd and other herds, you can look at and say, all right, here's the expected change in nefa over the first 3 weeks of lactation, shown in the black line. And then if we're getting this information in real time, and some of the work that we've done here at Miner, we were collecting milk samples from fresh cows on a daily basis, so it allows our herdsmen to make some decisions on what is this cow doing today, but also what is she likely to do tomorrow, and is she going to have a health problem, or is she going to be healthy? I like to use a traffic light type of approach, where red means there's an issue or that we stop and we need to take a look at that cow. Yellow means that these are cows that are probably doing okay or following a typical pattern, but maybe we still need to keep an eye on. And then green means this cow is doing well. She's well below, in this situation, the kind of average predicted blood nefa. And so this is a cow that's most likely healthy and doing well. Next slide, please. So what we see is that the pattern of nefa change that I showed you in the work from our farm is very similar to what is being shared with nutritionists and consultants and producers in your group here, and this is just one chart from there. I think the main difference that I see is that how we interpret cows that are in different parts of the lactation. In this case, again, it appears that you're using the red and the green type of approach. For me, I find there's value in changing my target values, especially in the first 1 month of lactation, because that change in nefa is extremely dynamic. And so for me, I interpret a cow that's at 800 very differently in the first week of lactation compared to a cow that is 2 weeks in lactation at 800. And so I think there's some opportunity that as we use this type of data, that we need to start someplace. And I think these guidelines are very good, indicating cows that are over 800 are at extreme risk of severe negative energy balance. The cows that are around 600 or so are at lower risk, and below that, we're not so worried. So as we continue to use more and more of this data, I think these type of recommendations will be refined, and that we'll see a sliding scale based on days in milk. Next slide, please. So in addition to using the milk predicted blood nefa, I think there's tremendous value in looking at the individual fatty acid groups as well. And so in this case, I just wanted to share with you the relationship between the milk estimated blood nefa increasing on the x-axis here. And when that happens, we can look at its relationship with the milk fatty acids on the y-axis, expressed as grams per 100 grams of fatty acid. And as we would expect, that when cows have higher level of blood nefa, that the preformed fatty acids increases in the milk. And we see that in the red line here. In contrast, we see a different relationship with the denovo and mixed fatty acids. So as blood nefa increases, the denovo and mixed fatty acid groups are decreasing. We can use this information then, understanding the relationships between denovo and preform in particular, to understand the risk that a cow has for developing a health problem. Next slide, please. So here's just one example that we see in the relationship between health and blood nefa and the denovo fatty acids. In this case, in the first 4 or 5 days of lactation, a cow had elevated blood nefa, around 1,200 milliequivalents per liter. And what we saw was the cow wasn't eating well, and her denovo fatty acids were also, they started out pretty good, around 20% or so, but then as lactation was progressing, denovo fatty acids was decreasing, and that's something that we should not see in fresh cows. Anytime the denovo fatty acids are decreasing, that indicates to me quite quickly that there's some issue with intake, maybe rumen health, but this is not a situation we want to see. Typically, when the denovo fatty acids are decreasing, the preformed fatty acids are going to be increasing, and that was the situation here as well. The data is just not shown. The cow ended up with abomasum around 14 days in milk. As soon as that surgery occurred, the cow is going to respond, if it's a successful surgery, very quickly. And what we observed was an improvement in how the cow ate, and that resulted in a decrease in blood nefa. And corresponding to those metabolic changes, then the milk composition changed, with de novo fatty acids increasing very quickly, as well as the preformed fatty acids decreasing. So we can use milk fatty acids, especially if we're able to collect that data in real time, to give us some indication of how cows are responding to interventions or treatments during this time period. So anytime I see de novo fatty acids much below 16 or 18% on early lactation cows, I get very concerned about their health and risk for problems. Next slide, please.
We're going to switch, and I'm coming back on. Thank you, Heather. Great job. What I'd like to do here in the last part is to summarize some information in my collaboration with Jessica McCart and her graduate students in the veterinary school at Cornell University. And these are some slides out of a presentation we did last October called Daily Roller Coaster of Blood and Milk Metrics. And one of the things that in working with Jessica, who's a veterinarian, that my question was, when we take a blood sample for blood nefa or BHB, does the time of day when we take the sample influence the blood test? Is there a right time or a wrong time to take that blood sample? Does it matter? And actually, it was an interesting question because Jessica didn't have the answer. So what she did, she's a very good researcher, she said, we'll get an answer to that question. And we designed an experiment to understand whether the blood chemistry was relatively stable during a day or whether it changed. If we go to the next slide. Actually, that's a grad student. So our objectives, you can get them both. Yes, to determine the diurnal variation in plasma BHB and nefa, and then the milk BHB, the milk predicted nefa, and the milk fatty acids on these same cows at the same time. So we're getting blood and milk composition together on the same individuals at high frequency. We wanted to determine the effects of ketosis on these diurnal or within 24-hour variation in milk and blood constituents. Next slide. So if you click through all the animation, let's get this up and I'll explain it because okay. So what we did, we had 28 cows that were not first lactation cows. We collected both blood and milk during days 3 through 9. The cows were in our Cornell dairy herd, and Jessica, being the excellent veterinarian she is, actually installed the catheter in each cow to allow us to put the catheter in and leave it in for the week and be able to take blood samples every 2 hours. So for a week on each cow, blood tests every 2 hours. This was done last summer. If you click the next slide, next one, okay, right there, we milk these cows 3 times a day. So the milk test is every 8 hours, but the blood is every 2. So we have a higher frequency on the blood. And what we want to understand first is how does the blood vary through the day? And then what we want to do is bring together in the same synchronization how the changes in blood are or maybe not related to the changes in milk. We were trying to answer that question. Next slide. So this is conditions at the dairy farm. A lot of graduate students who take blood samples every 2 hours, 24 hours a day for a week, requires an army of students that stay up all night. And they're very important. Next slide. So we analyzed the blood at the diagnostic clinic here at Cornell. The milk samples were analyzed on a machine just like VVB has from PerkinElmer. We analyzed the milk 3 times a day from each of the 28 cows through the study. Next slide. We, based on the blood test, so this is after the study's done, we grouped the cows by those that had a plasma BHB greater than 1.2 millimolars per liter versus the ones that were lower in that. So sort of a subclinical and a healthy group in terms of ketosis. Next slide. This, if we look at the x-axis, the lower part, we see the days of the week and the times of sampling. The red dots are when the cows were milked. The black arrows are when fresh feed was delivered. Fresh feed is delivered 1 time a day, and then feed is pushed up every couple of hours through the day. The cows that had low blood BHB are the blue line, and their plasma BHB is low. The ones that were higher are higher, and they're showing a cycling within the days. And usually the BHB in the blood is reaching a peak just after feed delivery. So it's cycling through the day, and you can see that the average cycle here on this at this point, we're at 1.2 and cycling up to as high as 2, where the cows that were low or not in a subclinical ketotic state are cycling much less, and they're staying much lower. Next slide. This is the nefa for the whole group of 28 cows. And this is an important slide. And Jessica, this answered the question I raised to her, is does it make a difference when you collect the blood sample? If you're only going to collect 1 today or 1 this week, the time of day actually seems to be important. And what's interesting is the blood level of nefa is going to be maximum just before the cows receive fresh feed. So if you change the pattern of feeding, it's likely going to change the cycling pattern of the nefa in the blood. So this is a very important sort of realization in terms of the concept of what we do and how we do things in management and feeding the cows actually has a direct influence on the behavior of the chemistry of the blood. So it matters when you take that blood sample, and you can see at one time of day where for the average of the cows, they're at about 500. So you'd multiply this value on the y-axis by 100. This is about 400 to 500. And another time of day, the average is nearly 800. So right before feeding. This is important to understand. Next slide. Here we show the plasma nefa. So this again is blood, and showing the two groups. And there's a little separation. The group that has the that are subclinical show higher peaks, but the same cycling in BHB or in nefa during the day. Next slide. So the conclusions on the blood, we see the diurnal patterns, or the pattern within a 24-hour period. Ketosis status did affect daily amplitude or the size of the swing up and down. But the question is, now that we know that this is all happening through the day in the blood, what's happening in the milk? Can we see this in the milk if we have every milking testing? Next slide. So the blood samples were collected every 2 hours, but the milking interval is 8 hours. So we had all the data from the blood. So we averaged the blood test values for an 8-hour period that put it in synchronization with the milking. And then we compared that data so that we've got 8-hour average blood samples, 8-hour milk samples to look at the cycling. Next slide. So here in the left, the lower one on both graphs is the plasma nefa. The upper graph on the left is the blood nefa averaged over an 8-hour period in the blood. So this is the group that was subclinical in terms of ketosis, the healthy cows. We see the cycling. And if we look at the milk, here's the healthy cows in the blue line. Within the day on the 3 milkings, we see the cycling. So actually, from one point of view, that made me very happy in that the milk is reflecting changes in the blood in nefa. The group that had higher nefa in the blood shows in the milk testing less cycling, but the milk distinguishes the two groups very well in terms of these cows that are the higher blood BHB show up much higher on milk estimated blood nefa than the cows that are healthy. Next slide. So something that's totally new is we said, so that's what's happening on the nefa. What's happening with the denovo mixed origin and preformed fatty acids? So the upper left is the graph, is the denovo, and this is the consecutive milkings during the week, and we'd expect to see some cycling. And we see the healthy cows are up on denovo that in the averaging up about 19. Remember, this is in the first week of lactation, so we're down in the 18 to 20 range. And we see this cycling through the day in denovo, which relates to the blood chemistry cycling. We see the cows that are more prone to ketosis have lower denovo, which is what Heather was talking about, but the cycling is less because they're not making much denovo. They're mobilizing a lot of body fat. So when we come over here, we've got mixed origin is doing a similar thing to the denovo, but when we look at the preformed, this bottom one at the left, we can see that the healthy cows, the blue line, are lower in preformed. They are cycling through the day, and we see the cows that are more prone to ketosis are higher in the preformed, and actually there's less cycling because they're just pushing a lot of preformed fatty acids into the milk, and in general, their dry matter intake is probably lower in terms of the status of those cows in what's happening. Next slide. So here, if we look at the preformed and the plasma nefa, so this is the blood on the bottom, and this is the preformed in the milk. The preformed is right in cycle with what's happening with the blood nefa. So that when blood nefa is high, measured in the blood, and we know that the milk goes up in its estimated blood nefa too, the preformed reaches a peak and it's cycling through the day. And this cycling is very much a function of how the frequency with which we deliver fresh feed to the cows. So I think one of the main messages is there's a lot of value sort of hidden in the milk fatty acid data that relates to blood and health status of the cow. But remember, this is high frequency milk testing. When you've only got one test a month on a cow, you can't see this. So for those of you who have seen some of my earlier presentations where I had kind of a video in it called The Cow of Interest, my long-term goal, and I still have energy left, is I really want to have a sensor in the milking system that gives this information to me every time the cow is milked. That's where I'd like to be. This data is really, I think, important for the future in terms of what we do in managing both health and productivity of dairy cows. Next slide. So conclusions on milk, the diurnal patterns or the within day patterns of milk estimated blood nefa and milk fatty acids are consistent with the measured patterns on the same cows from the blood. So this is really good news that the milk data is a solid way of getting information without taking blood samples. Ketosis status affected that daily amplitude or cycling, and in the overall relative percentages of the fatty acid groups. One of the things that we're seeing, and it's really not presented in this, is the cycling. When you look at grams per day, it looks like the denovo is cycling a lot. It's actually, when it's added up to 100%, if one goes up, the other has to go down. In terms of the synthesis and the output, it is the preformed that are cycling in grams per 100 grams of milk output. And the baseline of de novo synthesis is staying relatively constant. So that's something that we're learning in terms of understanding the data. Next slide. So the implications for the future, FTIR estimates. So this is the milk testing, Fourier transform infrared, estimates of milk BHB, and the milk predicted blood nefa as a tool for diagnosing ketosis seems to be a really good thing and would minimize the amount of blood sampling. The milk fatty acids in combination with the milk estimates of blood parameters help diagnose ketosis. I think we feel that actually, given that cycling, it makes a big difference when you take your blood sample, if you're doing blood samples. When we think about that variation and the importance of when you take the sample, the milk constituents actually provide a more stable estimate because it's averaged over what the cow did for the last 8 hours. So that it's going to be less noisy and more stable in terms of the data from the milk than blood testing. So ultimately, the point, high frequency real-time milk testing would be of value in health management. We're not there yet, but that's one of my goals for the future is I want to have a sensor right in the milking system that tells me this every time the cow is milked. So I always have big goals. I'll continue that way. Next slide. And if we've got a little time for questions, FTIR, Fourier Transform Infrared, rules. That's the license plate on my car. Thank you.
Okay. I've seen in the chat, I have been listening carefully to your presentation, and it's, yeah, I didn't promise too much because there's always information, there's always new information, and to me it has been very enlightening, and I want to thank you, first of all, very much, the two of you, for showing us around in the wonder world of the fatty acids and the nefas. It was a very, it answered a lot of questions. Still, there were also questions. I saw some in the chat. I saw also that Dr. Dan answered several of those questions. I don't know what is wise now. If were all the questions answered good? Not all of them, I hear here. For example, I saw one where somebody asked about Jersey cows. There was a question about the denovo values were 27, 28, and the rest of the herd were some over 30. If that data is also useful for Jersey cows. That was the question.
Yeah, so at least the way I interpreted it was that in troubleshooting early lactation, those values for de novo were much higher than I would expect based on the type of information that we're seeing here for Holstein cows and for Jerseys as a percentage of the total fatty acids. But I would recommend using the same kind of general guidelines for Holsteins and Jerseys when we express the fatty acid groups in grams per 100 grams of fatty acid. However, if we express it in grams per 100 grams of milk, then we definitely need to adjust our values for Holsteins versus Jerseys, where Jerseys in that case would have higher expected values. While Dr. Barbano was finishing up, I pulled up a paper that was looking actually at fatty acid profiles of Holstein and Jersey Danish animals, and it looks like that the fatty acid composition is fairly similar as the percentage of the total fat. So I feel comfortable with that type of recommendation. Dave, anything to add to that?
No, I think that's good. And I think that generally the relationships, if within Jerseys and you're watching Jersey cows and a Jersey herd, there probably is some different baseline level for the Jerseys in terms of fat de novo as a percentage of the total. But if the de novo on a fresh cow is too low, for Jersey, you're going to have the same signal in terms of a problem. And if we had higher frequency, I find that after the first 3-4 days, in that first week, if the de novo as a percentage of the total is decreasing on any cow, that's not a good sign. She's having a problem.
How do those, I think the question came in, there were a lot of de novo values over 35, and that's something that we don't typically see here in the US, at least with how our systems are calibrated. Not sure if that's something that's more routine there. So any comments on that, Dave?
Yeah, I think that this last week, for the first time, we managed to get samples through customs of our calibration samples, and we're working on that. The numbers seem to be a little high off the data that they're getting, and maybe they're a bit of an overestimate, but the relationship, in terms of stage of lactation, is still showing the same trends that we'd expect. It just seems to be lifted a little higher, and that's easier to manage when you have access to information for all three groups of fatty acids and can see that everything is synchronized and working well. And I'm going to be working with the VVB lab group to try to focus on that and look at the data.
I'm wondering if there is more questions that are not answered yet. We are question for VVB, we see here. What are the experiences so far with the analysis of herds and individual cows? How many cows seem to experience problems? The NEB status after calving. That's a question that I could also answer in Dutch. I will try to do it in English. You're asking if we analyzed actually how many problems there are, and the truth is, maybe Marissa, you can help me. We have ourselves as VVB, we have not analyzed that, but there are some feed companies that are very busy with doing that. Maybe it's interesting to gather some of those information and spread it under the followers of this webinar, because I don't want to come with conclusions that are not 100% correct. But we see in practice, Marissa has called a lot of farmers when values of individual cows are high in terms of blood nefa, or low in terms of denovo, or the combination of the two. And when you call farmers and you try to find out if they also experience the health situation in the barn with the cows, the conclusion is usually that yes, there is a problem, and often there is a practical solution. And sometimes you see that the cow is soon leaving the farm because they cannot manage with that. So it has a lot of practical value, the numbers that are given.
I'd just like to add in that here in the US that we've seen a decrease in cows having clinical ketosis on many farms with improvements in diets and management. But I think the advantage of using some of the milk analysis is it allows us to detect subclinical ketosis that a farmer may not be able to just tell by looking at a cow, right, by definition. And so the milk composition, the BHB level, the amount of nefa in there can give us an idea. And what we see is up to 40% of cows on well-managed herds here in the US can have subclinical ketosis. And to me, that indicates an opportunity to modify what we're doing to the cow to control that negative energy balance better.
Also, I'm working with a group in Italy that's set up to do this testing now in the north of Italy. And we are working with a group of farms, and we're finding very clearly that when we identify from the milk composition data that would indicate there's a problem, and then the field people check with the farm, we do confirm almost always that there is a problem and that we could have reacted to it sooner if we follow the milk composition data. So we're seeing that in a lab in the north of Italy also.
What is maybe interesting to add is an example that you have given the other time that you gave a presentation, Mr. Barbano, because then you were talking about a farm, a huge farm in the States, where they collected the milk 3 times per day. And you were monitoring there the denovo values, and the strange part that you noticed was that during the day, the denovo changed a lot. It was 16 hours, it was okay, and 8 hours, it was very low. Do you remember what I'm talking about? Maybe you can.
Yes. Excuse me. This was a farm, a large farm, that had 3 times a day milking. They actually, 3 times a day at the farm, the milk was picked up in a big tank truck. And what we discovered based on surveillance on the farm is that during the night, the feed was not being pushed up to the cows, and the cows had no access to the feed. In that milking after that, the denovo was low, the nefa was high, so the cows were hungry and they were mobilizing body fat, and the fat test was low. But what was interesting is the MUN, the milk urea nitrogen or urea, was about half the normal level because they didn't have feed. So we can use this to monitor, and actually in farms where we have every pickup testing, I can tell when different people are feeding the cows on the weekend because the pattern changes in the milk composition. And I can tell whether they're doing a good job or not so good job. So it's very useful. High frequency data is very helpful.
Okay, thank you very much. That was a very clear example, I think, from measuring in milk how useful it can be. While you were giving your answer, I noticed your hobby again. I hear the clock, and probably that was an alarm for us that our time is finished now, more or less. It's 5 o'clock, and we have had 1.5 hours with a lot of interesting information. I think very helpful for everybody who followed us. The nice part is also here we can see in the screen how many followers there are, and everybody stayed almost until the end. So everybody wanted to see what you have to say. Answering questions is pretty hard if people cannot really ask a question, only by chat. So my proposal is to collect the questions and to see if we can answer them. And otherwise, maybe there is a chance to, in some weeks from now, that we do a session with only asking questions where people are not muted. So that means that I want to finish this webinar. I want to thank everybody who followed it. We are very excited that you are interested in what we do, and we hope that you can use it in practice to help farmers in their management. And of course, thank you very, very, very much, Mrs. Dan and Mr. Barbano. It has been very enlightening what you've told us, and we are very grateful that you were willing to make time for us and for our consultants. The last thank is to the people from Uniform Agri, because they helped us through this webinar. For us, it was the first time. It was interesting, and well, we're satisfied about how it went. Thank you very much.
Okay. Thank you.
Thank you.